Hello, all. Welcome back to our course on digital accessibility. Today, we have planned a very interesting session and we have invited a very experienced guest to interact with you all. So, today we have Dr. Vikas Upadhyay, who did his PhD from IIT Delhi, and he is the founder of iWay Plus. He holds a bachelor's and master's degree in electronics from the University of Allahabad. Vikas is currently leading technology development at iWay Plus, focusing on analyzing and annotating indoor maps to create advanced wayfinding solutions for persons with different abilities, primarily focusing on persons with visual impairment. So he has successfully implemented multiple projects in collaboration with big organizations like AIMS, WHO, CRO, etc. For his contributions, he has received several accolades such as the Inclusive City Award, Octane Challenge, NASCOM, Healthcare Innovation Award, and we are very glad that he is here to share his experience and knowledge with us. Thank you, Vikas, for joining us today.
Thank you, Richa.
So maybe we can start with you can maybe we can start at the point where you can tell us about the challenges that you are trying to solve through your work.
Yeah, thank you first of all for inviting me here. Like during my PhD, I encountered a very interesting problem of helping people with visual disability to navigate in complex, large indoor spaces. And this was a problem which I thought as a PhD problem, but at the same time, there was few doctors from AIMS also approached us and mentioning that they have patients who are challenged in experiencing a wayfinding challenge in their day-to-day journey in the hospital. So we came across this problem to be more universal in nature, not just people with visual disability, but it has a potential to helping people who are visiting a hospital or any building, any complex building for first time to navigate independently. And in context to visual impaired or other type of disability, definitely this is a very big challenge to be more independent. When they willing to go somewhere, they have to be dependent on someone, and that is the problem which hit us, and we started working on that problem, and that was the very initial start of the problem.
Yeah, thank you for that very interesting overview. So let us like dive deep into the various aspects of the things that you mentioned. So, what is your process for involving different people with a variety of disabilities? As you mentioned, that it problem was not just limited to people who are visually impaired, but it would extend to larger audience as well. So, was there any specific processes involved which would help you include people with visual disabilities, cognitive disabilities, mobility impairments in the user research or testing phase? So,
Yeah.
how do you do that?
Yeah. So we belong to a lab which is assistive technology lab, and this lab is focused for people with visual disability, and which is located in IIT Delhi in Computer Science department. And this lab is doing this work from last more than a decade now, helping people with visual disability to navigate basically into their mobility and educational problem, to be more independent on both in education front and the mobility, because these are the two fundamental elements which can make them actually empowered, actually making them more independent and self-reliance. So these are the things which we found, and the people with visual disability, definitely the strong community behind which was already associated with lab, who were taking part in the focus group discussions and semi-structured interviews and many other processes since beginning of this idea or the research. And at the same time, we also get more input from other institutions, like IIT Madras is more focused for people with locomotive disability. So we get a lot of feedback about locomotive disabilities and discussions with them and their group, Professor Sujata and their group, which work on locomotive specifically. So we try to understand from their perspective what are the challenges for a wheelchair person when they start navigating independently in a large space. Similarly, for cognitive and other type of disability, we try to understand multiple disability organization who handles with people with multiple disability, try to understand what are their challenges in their life. I would say, like, we try to incorporate as many as possible in our initial discussions through our focus group discussions or through semi-structured interviews or the surveys which we conducted, to understand how their navigation experiences are at different places. Like if they go independently or with someone, what type of space are the more challenging one, what are the less challenging space, and what are type of challenge they have. So this was the initial thought on that we include as many as possible to understand the problem, to understand the need. And this was the huge need assessment studies, which goes around 3 to 6 months during my early stage of PhD.
Oh, wow, very interesting. So, how do you handle the challenges of implementing navigation systems in environments where the layout is constantly changing? So, for example, you mentioned that you have tried to implement it in AIMS and all other hospitals also. So, somebody somewhere like a busy hospital or a museum with changing exhibits, or how do you implement?
Yeah, so this is very interesting problem. Actually, when I was doing PhD, that time we never thought about that. This is something which we encounter in like we were thinking of frequency to be like 3 months or 6 months, or maybe in a year we need to do a survey. But when we do in actual field, we found this could also happen in a day. So we need a system which can update and do these changes frequently as fast as possible. So what we do, like we not just do a digital mapping, we also build a content management system and other tools which our client, or I would say hospital, or a museum can handle by their own. So any smaller changes which happen in on day-to-day basis, they can do their own by simply just uploading an Excel sheet, or doing a smaller changes. Our second option, we also given them, if they want to do those changes immediately, they can also share over these changes to us, and we will do it from our side. So there are multiple channels which we provide them, through which they can update these changes on day-to-day basis. And we also provided some kind of scheduling mechanism on the map itself. Like if they have certain things which is going to happen for particular days in future, coming dates, they can schedule it on the map. So it automatically appears on the map and disappears just after finishing the particular schedule. So those are some advancement which we did. Also, besides this, we now working on automating these things, where one can simply upload the data, whatever format they have, and the map and everything get updated automatically. So using advanced AI techniques. So yeah, these are the things which we now doing on day-to-day basis to do the changes. Yeah.
Oh, that's good to know. In order to now trying to understand the technological implementation aspect of it, so what are the core technologies that you are using for indoor positioning, and how do you choose the right blend of various technologies in order to maximize accuracy for accessible wayfinding?
Okay. So this is again a very interesting and challenging problem of indoor wayfinding, like the indoor positioning technology. We all know GPS doesn't work inside the building, so you need to rely on some alternate positioning system. And if we talk about positioning system, there could be a sensor-based positioning, there could be sensor-free positioning, both. Sensor-based positioning methods rely on Bluetooth beacons, or some environmental sensor like UWB, ultra widebands, or Wi-Fi, or even QR codes and other things which can be deployed in the environment to help you identify your position. Now here comes to what positioning technology is more suitable. So it completely depends on which use case you are going to use it for. So like UWB is give you positioning accuracy at centimeter level, but it has a challenge of power hungry. It's required to be connected with mains power. It is costly also, and it also not directly available in all the smartphones where you can use for positioning. Second, if we talk about Wi-Fi based positioning, it is I would say much cost effective, but the positioning accuracy is very poor. Second, another thing, like Wi-Fi is not inherently been placed for indoor positioning purpose. They have been placed in the environment just for providing you access to Wi-Fi network. So their placement is optimized for that purpose only. So you may get many blind spots where the Wi-Fi signals may not be available. So for positioning in those areas, you need to either add additional Wi-Fi routers, or you need to go for an alternate sensor technology like Bluetooth beacons or something. So third one is the Bluetooth beacon, which we also preferring currently, and this is the current market standard for indoor positioning technology, where people using small Bluetooth beacons, which are battery operated, which goes for 3 to 5 years easily, based on a coin cell battery, and it has no privacy or security issues also involved with it, easy to install and maintain. So, and it gives you an accuracy around 1 meter, which is fair enough for people to navigate in complex spaces. On the other side, vision based positioning technology is also there, but using them into a product in real use case is might be little challenging, because of the environment may keep on changing. So you need to kind of remap the whole space in terms of for visual positioning. You need to capture the images and the data from the indoor space so that you can do a visual positioning accurately. And these data keep on changing constantly, so you need to capture those data. And in crowded environment or certain conditions in India where lot space are a lot more crowded, there also the visual positioning may have challenge. So these are the piece of technology. So whenever you select which technology to choose, you need to see your space and your target audience. I would select, as of now, I would suggest to use Bluetooth beacon for indoor positioning if you're going for people with visual disability and other to navigate. But you can also think about using Wi-Fi and extended network of Wi-Fi to give it a better alternate to beacons. Yeah.
Hmm. So, as you rightly spoke about crowded spaces, particularly in Indian context, so how do you ensure systems performance and accuracy remains robust in different building environments, such as during periods of high Wi-Fi traffic or Bluetooth traffic interference?
Yeah. So it's important to understand here, like any wireless technology get affected by human. So if
Hmm.
presence of human always affect the signals, their strengths. So if you rely on those technology, it will be affected. The accuracy will be affected. So one way to counter is like you can increase the number of sensors in those environment where a lot of crowds are there, or you should have a robust data available from those spaces, crowd density data over a period of time, so that you can improve your algorithms to kind of take a factor into the environmental factor into account while you're doing the positioning. So beacons and the other sensors which transmits this radio signals, they definitely varies from the presence of human. But if you have a data available from the history of the crowd density, you can estimate a better positioning. So that is the one way to do. Either increase the number of sensor, or you should have a better model of crowd density estimation in the building so that you can improve your algorithm for positioning.
Hmm. Okay. So, if since we are talking about Indian context, and there may be a lot of hospitals or buildings which are not as modern, so how do you work around the older infrastructure of buildings which are not equipped with, say, Wi-Fi routers or all of that?
So for older buildings, we encounter like a few challenges. One is like obviously in terms of the availability of floor plans. Many times we don't have floor plan available for very old buildings. So we may need to either get a hand sketch drawing, and sometimes we need to do a physical survey of the space to create a digital map. So that is one level of challenge. Second, we also encounter sometimes there's heritage buildings specifically, they don't want to do any alteration for
Hmm.
your requirement. So there, if we going to install something which either affect their look, will not be very acceptable. Any
Hmm.
alteration in their environment may not be acceptable. So in that case, putting a Bluetooth beacon, which are like just sticking using a tape, a double-sided tape, might be still acceptable if you can place them properly. So those are the challenges, and we currently encounter through getting a minimal kind of alteration in the environment itself. For mapping, obviously, we need to do a survey and do this so that we can create a digital map. But the good part is once you map these spaces, they also have now a repository for their own purpose and referencing. So
Hmm.
that's how it helping a kind of solving a problem on the other side also for the organization who have such older buildings. So yeah,
Hmm.
so this is the advantage.
Hmm. Hmm.
And obviously, some physical retrofitting is still required for many of these older buildings to make it physically accessible. But yeah, digital accessibility still can be made without much of the alteration.
Hmm.
One interesting thing here also, like sometimes physical tactile tiles and other things which people do not want to place because of the it's either heritage building or it's a old infrastructure which they don't want to alter. So in those cases, this digital navigation system is definitely a much better alternative for them.
Hmm.
So this is how it's getting accepted in those buildings and venues.
Yeah, yeah. I'm sure like the bigger forts and palaces of our
Yeah,
countries can benefit from this system, and a lot of tourists who
yeah.
come there can also benefit. So, since now we are moving the conversation more into the human aspect of it, so let's talk a little bit about the interaction part of your technology. So, in what ways do you try to incorporate non-visual feedback cues? So, what are the different ways you are enabling the system, the users to understand the spatial things which are non visual? Because primarily your users are visually impaired.
Yeah. Yeah, this is also very interesting part when I was doing research. So I try to understand how I memorize route from my home to my office or my lab. So when I visit, I definitely follow certain visual cues from like a place where we going day to day basis. So we memorize latently many of the visual cues in our memory. Similarly, we try to understand then like what could be a visual alternative cues for people who are visually impaired. They cannot see, so they don't have an option for getting a visual cues. So for them, a lot of other sensory cues are considered to be the I would say latent cues or the cognitive cues which they memorize or they kind of learn over a period of time. Like a tactile is one very prominent cue. So they kind of any surface change or any change in the surrounding, which is kind of a nature of tactile, they memorize into their memory if they keep going that route day to day basis. Second, we also identify other sensors besides vision like touch, smell, or sound. These are the factors which kind of create a cognitive map. So, if a people walking from his like a person with blindness, suppose walking from his hostel room to a particular classroom, he might be having tens of such cues which are just parallel to this visual cues. I would say which are non-visual cue for people with visual disability. One prime example is like a person counting the road bumps as a tactile cue for them. Like he count after 3 bumps, I have to take a right. Similarly, a person can smell a coffee which is passing by daily, so a coffee shop, which might be a cue for him that after coffee shop I may get my office in 5 minutes walk from here. So those are the kind of non-visual cues which people always remember. Even the humming sound of a fan or a AC or a water cooler. These are the things which people many times remember. Or even like we during discussions we found like people walking across the corridor, if they know the with the flow of air, they also can understand that there is a junction upcoming. So those are the things which are non-visual cues, but this they never happen just in one day. It happens over a period of time. Like people keep memorizing in their memory and creating a cognitive map using these non-visual cues, which are very interesting to see and understand. And embed these cues in the map definitely can help the happening this much faster. Like suppose if they're using these cue in and learning a map or an environment in 3 months, if you embed these things, definitely it could happen much faster. In like 2 or 3 times uses of the map with these cognitive cues, they can learn their environment and surrounding much faster. Yeah. So
Yeah, I think you were earlier giving a very interesting example of somebody who kind of memorized the route of, your office in IIT Delhi from the main gate of IIT Delhi. Maybe you
yeah.
can elaborate on that
Yeah,
example.
yeah. So that is very interesting example. So one person like GPS, he doesn't use either any navigation app to take a right turn or left turn. So I curiously asked him like how he get to know when is the right turn for him, because he's not using Google Map or any map to navigate. So then he says like I came daily and I found one bump like which is coming across the road. When I walking, I can feel that bump, and whenever the bump I cross 3 of the road bumps, I know that now whatever next turn is coming, I have to take that turn. And once I take that turn, after like 2 minutes or 3 minutes walk, I will get another left turn, which will lead me to the building where your office is located. So this is the how I remember things, and I really surprised that they are so settled that they don't even need to count it. Like they don't need to count like 1, 2, 3. They this is something which is going back of their mind, just like us. Like we if we going daily on a particular office, we can easily navigate without thinking or looking into map. Or suppose you are in your house and you completely the light is turned off, still you are able to figure out your kitchen, your washroom, your other things without seeing anything. So it's you also work on something similar principle. You have a cognitive map of your own where you can see like when the wall is going to end. You definitely take a turn without seeing it. So those are the cognitive map, and this was very classic example for us to understand and drive much deeper into understanding what are the factors which help people to create these cognitive maps. And yeah, so these are the interesting factor. And while doing this research, we also found like these cognitive maps are not a very kind of a variable for different people. Like most of the people with visual disability use this cue in day-to-day life. So this is something which is still is something which you can count which you can understand how they're using in day life. Yeah.
Yeah, I think it's important to understand from such examples and what we have been discussing so far. The key point, which we have also discussed in one of our lectures, that from a framework or a process perspective, is that it is essential to understand how your potential users will interact with the environment to begin with, and how they are adapting without the existence of any interference with the environment. So basically, what are the adaptability which they are already doing, the jugards that they are already doing. So there is a lot to learn there, and I am sure the example which Vikas also mentioned is along the same lines. So, Vikas, you mentioned about the cognitive map and overload aspect in your example. So, how, and also you mentioned that there can be multiple non-visual cues such as audio cues or tactile cues and all of these. Uh, how do you understand where to draw the line so that it doesn't become a cognitive clutter?
Mm.
Because in multimodal design, many a times, of course, as part of the process we always discuss ki, give options, include multimodal feedback systems, this and that, but then where to stop, what is the optimal, how do you define that?
Yeah. So one is obviously going iterative testing with people. That is a very obvious practice and common practice. But there should be certain protocols also which we should follow, which we usually follow in our signage based system or other type of information communication system, where you try to do a progressive disclosure of information and strategic placement of information. So when we say progressive disclosure or strategic placement of information, that means like when I am walking on a route, I definitely need a minimal interference while I am walking. I need the information which is more critical to achieve my task of navigation. So you should prioritize those information. One is like obviously you can go for a explore mode where you can bombard information, considering that the person wants to know those all information. But that is still that is something which is not acceptable by people. So you need to figure out through multiple iterations that what are the type of information and what are the channels you're going to communicate with, and mapping those two things is important. Like for suppose if person wants to navigate, there could be a directional information, like you have to take a left turn, you have to go straight, you have to take a right turn. So these are the directional information which is very critical for navigation. So you need to always communicate very clearly and crisply through audio, and that's what we understood from while doing the testing. Besides this, if you're passing by a landmark, so passing by a landmark information might be useful for people who are coming for first time, but if people who are daily visiting a space, might not be very useful. So you need to kind of reduce your information load slowly once the person started using it. Also, adding more channels like haptics and other, it depends on the piece of information. Again, like if you want to put an alert, suppose a person with visual impaired crossing a road, you can give him an alert through beep and vibration so that he can feel that alert, that there is something which is dangerous for me and I need to be more aware of, because the audio might be stagnating because he is listening to many other things. So you need to kind of keep on changing the mode of information communication, like the haptic, audio, beeps and all. And you need to make a balance of it so that it should not be looking a very cognitively overloaded for him. So obviously this is something which your algorithm or program should define progressively. Like a person who's coming for first time may need more information. A person who is visiting frequently may need just a very focused information. So your system should be adopt to this, understand what type of person he is, what type of information is critical for him, and depending on that, you need to keep all the information, all the possible mediums, but you cannot use all of them with each person. You need to figure out which person, which type of medium is better, and based on that, you kind of reduce those overloads while they're using these systems. So yeah, that is the way we are doing. And also you should give an option for end user also to configure these choices at certain extent, so that they can also decide what he want to listen and what he don't want to listen. So yeah, so these are the ways where we are handling. Besides this, I understand like identifying the priority of information in your instruction set itself is a very critical thing which you understand by performing these iterative tests with people with disability. Yeah.
Yeah. So I think in your answer, you mentioned two critical points. One is continuous evaluation of your solution or technology. So we would like to understand, first of all, what are the different methods with which technology like this, which also is environment dependent and also has a handheld kind of an interface through an application, how do you evaluate that? What are the methods that you have used? Probably our audiences can learn from it. And the other aspect which you mentioned, that how we can customize the solution as per the specific needs. So what is your understanding of how AI in today's day and age help with that customization? Because in a lot of digital interfaces, AI is helping a lot for customization. Is it useful in this kind of a scenario?
Yeah. So starting with this first thing, like how we evaluate these systems when we going into field or giving this to end users. First, like we have like certain protocols to follow. Like we give user to do a supervised trials where we kind of go with the users, see and guide them, helping them. These are the functionality which you can use in the app, and this is how it's going to use. Then we do a semi-supervised type of trials where we can just see how they are using. Once you tell them these are the features and these are the functionalities, so then in the semi-supervised we kind of just monitor them passively, and then we go with the unsupervised type of trials. For these all things are for field trials, so bringing confidence in our users, also bringing confidence in our evaluation system. We go with this supervised, semi-supervised and unsupervised trials, and this also help to bringing confidence in, so that they can understand the protocols, study protocols. We can also evolve our protocols, and once we go with the unsupervised trials, we will be able to assess what type of feature they are using or listening more. We kind of conduct the interviews with them to understand what would be the beneficial, what are the features they are like found most useful one, what are the less useful ones. So those interviews and semi-structured interviews and discussions help us to understand in unsupervised trial what are the things which are really important for them, from starting with the supervised trials. So these are the things. Second thing comes on the customization part. So you cannot customize everything for end users, because everyone has different demands you may encounter while you're doing this testing. So you need to figure out and to break down into very limited options of customization. You should have a same backend. You should have a front end which can be customized as per the person with disability, giving certain options for them to choose. Like for example, if a person with blindness want to use a natural direction versus a clock direction for referencing, that they can use. If a person wants to use a step count into feet or a meter or number of steps, so those type of customization still can be given, uh, but not the complete customization you can do for each user. Otherwise, you will lose the universality of your design. Third is like putting AI into it. Yeah, that is something which we definitely see a lot of potential which is coming. For example, any interface we so far we tested in the navigation system, we found a chatbot is an example, like ChatGPT or any chatbot, which is so universal interface that any child, from a child to a elderly, anyone can use that interface very seamlessly without thinking of much. So AI can definitely do those wonders, which where you don't need to think about any interface for map and navigation system in future. You may be thinking just a chatbot which is guiding you all your navigational need in just a one interface, uh, where you get the relevant information while you're navigating through that chatbot itself. So definitely the AI can understand the user's requirement, set of questions, and generate or curate the answers which they are looking for. Rather than putting into a layer of interfaces, you can simply feed this information to a AI bot, and it can definitely respond to those questions more appropriately in a linear interface like a chatbot. So those are the things which we definitely believe the AI can change those interface thought process for doing those interfaces, which definitely going to happen soon. Yeah.
Yeah, good to know that. because it definitely reduces the cognitive burden of users, because they themselves don't have to navigate
Yes.
through the interface.
Yeah.
So, and also, as you rightly said, that it's a linear interface. So, it's just one input, for example. It can be text, it can be audio, it can be multiple ways.
Yeah.
So, I had this kind of a crazy use case for you. I don't know whether currently it is your system is incorporating that. So, what role would your system play during an emergency evacuation kind of a thing? So, how does the guidance systems adapt to addressing like safety of people who are disabled?
Yeah, so this is really interesting and kind of a universal problem, not just in India, across the world. Like emergency evacuation is very critical task, and we may have this floor plan or emergency evacuation plan, which might not be even accessible for people with sight.
Correct.
Because in case of emergency, you don't have enough time to go and check out or search for an evacuation plan and follow that. And for people with different type of disability, this is completely inaccessible because it mostly shows the stairs and other paths. Suppose a wheelchair person standing on the first floor, you shut down the lifts and you also showing a path which is going through stairs. It's completely making him annoyed and like a life threatening kind of things. So our system still has a potential to kind of guide a person in a way like what could be the nearest point where they can either it could be a kind of a, I would say, fire exit point, or I would say the refuge floors, the nearest refuge floors there they can reach through using their wheelchair. There are some buildings they have specific lift for fire evacuation, so it can guide. So basically, how this will happen? So in our system, we have mapped all the emergency exits also. We know the user's current location. So if the admin, whoever is the building administration, want to trigger an emergency evacuation SOS or a particular alert, it automatically triggers on everyone's phone who are in the building, and it's showing the nearest exit from their current location, and it automatically pop up on their phone, which they can follow to immediately evacuate the space and identify where they can collect themselves to get evacuated. So these are the possibility which these systems brings without irrespective of the environment. Like you can even collect them to a balcony or somewhere where which could be the safest place for a wheelchair person to go if your building is not completely accessible multi-floor in case of emergency. So those are his potential strong use cases which the system brings into overall aspects. So yeah, this is how it helps people getting the emergency evacuation.
Yeah, great to know about all of the various aspects of the system that you have built and successfully deployed in so many places. Now, maybe for the benefit of our audiences, you can tell us a little bit about what are the different requirement of expertise or skill sets or tools which you have used in this entire journey, be it development, user research, evaluation, so our audiences can also benefit from, learn those tools or skill sets and try to, build and contribute to such use cases.
So yeah, obviously this is having some technology depth involved into it. I would not say it's a very straightforward to build a map and the navigation system by your own. But still, when we started, when we don't have any technology available, what we did in a very early stage, we kind of generated a route description by writing them down. So if you have a very small space, I would suggest like you can draft the route description from your entry to those 4, 5 or 10 locations which are very key to your building without relying on any technology aspect. You simply can imagine from main entry of your building. Suppose there are 10 different locations where like your 80% of crowd is coming to visit. So for those 10 routes, you can generate a more human-centric oral description, audio, or maybe a text description, and you can definitely share those descriptions to your visitors or whoever coming to make your space accessible for navigation in a very kind of a very early stage without any technology, without any additional resource. That could be made possible without any kind of understanding of technology or any expertise. Second level of think is like you can definitely, we have our tool where you can kind of use your floor plan to annotate and create a digital map. Some part of our tool is open source, I would say, where you can go and check out and update your floor plan, annotate your floor plan, and make it available for your visitors. you can share a link to them where they can use that link to kind of generate a route preview and see those information on map. Because description has a limitation, like you cannot describe all your destination at your venue if you have hundreds of locations where visitor can go. In the first step, definitely for a smaller building, you can describe and share to your visitors. Second stage possibility is like you can use our tools to create your map and then help people to reach to different destination. And third is like definitely you can approach us or our team to get it done by us, where we going to map and put these beacons and put a navigation system live on the application. So those are the three possibilities which one can make their spaces accessible. So yeah, these are the ways we can do.
So thank you, Vikas. And we will surely share the open source tool links as an appendix to this video. And of course, maybe you can visit those tools links and try them out for yourself, and maybe try to annotate your residential complex or your nearest hospital or your school for that matter. So any closing remarks from your side, Vikas?
Yeah, so I think we all are looking forward to make spaces accessible, navigable. Accessibility might be a condition, I would say, what I realize, and it could be with anyone. It's not a limitations for only with limited to only with person with disability. Any person who has today is able may not be able tomorrow, given that certain conditions. So we need to make our environment, our places completely accessible for us, not just for people who are around us with certain disability. So making this system available readily in our houses, in our places which where we are going, is enabling us, not just people with disability. That's what I believe. So that's why we make our space accessible today for people with disability, and hence tomorrow for us. That's what the thing I think.
That's a great thought. And we again thank Dr. Vikas for being with us and discussing his work and his journey with us. And I'm sure all of you might have gained a lot of insights into navigational challenges pertaining to different use cases and different persons with different disabilities, and how we can make our common spaces more accessible is something of a very big problem. And of course, all of you can also try to contribute to it, and this is just one of such problems. And as part of this course, we will keep discussing, and will keep bringing more such experts to interact with you all. Thank you for joining us, and we will see you in the next session.